Equations. Equations are different from expressions because we have an equal sign, we have terms on both sides of the equal sign, and when that happens, it means we can't just pick anything we want to substitute in for the variables. There are a limited number of variables that will make the equations true. To solve an equation, our job is to get the variable on one side of the equal sign by itself. To do that, first we need to locate the equal sign and define what our two sides of the equal sign are. Locate your variable, and then our job is to isolate the variable. We do that by, it's kind of like untying a knot, undoing what's been done to your variable. In this case, we've got an x and 4 has been added to it. If I need to get x by itself, I need to get rid of a plus 4. I do that by doing the opposite operation, which would be minus 4. Following the rules for combining like terms, x doesn't combine, but positive 4 and negative 4 combine to make nothing. Now I can do that as long as whatever I do to the left-hand side, I also do to the right-hand side. Following the rules for combining like terms, I get 5 minus 4 equals 1. So the answer to the equation is 1. What that means is 1 is the unique number that if I go back, plug in 1 where the x was in the original equation, I'll have a sentence that's true. And 1 plus 4 is equal to 5. So my equation checks. On number 2, I find my dividing line and locate my variable. Then I identify what's been done to my variable. In this case, I've got 9 subtracted from it. This means I need to add 9. Combining like terms, y doesn't combine with anything, but a positive 9 and a negative 9, they combine to make nothing. I could do this as long as I follow the rule. Whatever I do to the left, I have to do the same thing to the right. So if I add 9 to the left-hand side, I add 9 to the right-hand side, and 13 plus 9 is 22. That means 22 is the unique amount that'll make this a true sentence. 22 minus 9, does that equal 13? It does. Therefore, my equation checks. Now, it may look scarier when I have fractions or when I have decimals, but it doesn't change anything. I have a calculator to do the actual computation. The rules stay the same. Locate my variable. Whatever amount I've added, I subtract from both sides. Positive 3/4 minus 3/4 makes nothing, and my t is alone. Now on the other side, I have 9/10 minus 3/4. Again, I have technology available, so I type that into my calculator, and I'm going to state the answer as a fraction because the problem came with fractions. And the answer in a fraction is 3/20. I can use technology to find my answer, and I can use technology to check my answer. Plug in 3/20 where the t was, add 3/4 to it, get that answer and change it to fractional notation, and the answer should be 9/10. If it is, my answer checks. Decimals, again, doesn't change the steps, just might make them a little messier, just need the calculator a little more. If I add 7.3 to both, or if I add 7.3 to my variable, to get rid of it, I need to subtract 7.3 from both sides. I combine like terms on the left, that leaves my r by itself. Combine like terms on the right, following the sign rules. or making sure I type it into my calculator correctly. Check. Negative 15.9 plus 7.3 should equal negative 8.6 in order for this equation to check. Now, these are a little bit different, only in that the operations that are being done are a little different. In this case, I locate my dividing line, I locate my variable, and I don't have things that have been added or subtracted from my variable. Instead, I have a 5 bumped up next to it. Bumped up next to it means multiply. To get rid of something that's been multiplied by my variable, I need to divide by it. And again, the same rule applies. If I divide it on the left, I divide it on the right. 5x divided by x, 5x divided by 5 leaves you with x. Keep your equal sign in the same place. And negative 45 divided by positive 5 is negative 9. You want to check, make sure you preserve the operations. I want to do 5 times negative 9, that should equal negative 45 if I've done my work correctly. That problem wasn't supposed to have a second x, so let's ignore that. Find my dividing line. Negative 7 times x means to solve for x, I need to divide by negative 7. Follow your sign rules. Negative divided by negative is positive. 7 divided by 7 is 1. 1x is the same as x. 0 divided by negative 7. Well, 0 divided by anything is 0. Check. Is negative 7 times 0 equal to 0? Yes. And what about number 7? Number 7 looks like it's done to me. Problem is, it's got a negative in front of the x. You have to have the x totally by itself or the problem is not solved. Remember when we were combining like terms that if there's not a number in front of your variable, there's that little invisible 1. I don't have just a negative in front of my x, I have a negative 1. To get x by itself, I'm going to divide by negative 1, the same as I did just a minute ago when I had to divide by negative 7. So negative divided by negative is positive. 1 divided by 1 is 1. X equals, on the right hand side, negative 4 divided by negative 1 is positive 4. When I substitute in 4, negative came as part of the problem. I plug 4 in for x. Negative parentheses 4 is the same as just negative 4, so my answer checks. What if I am dividing by, or what if I'm multiplying by a fraction? Well, there's a couple of ways of doing this. It depends on whether you want to pick up your calculator or not. If I have 1/3 times x, there's nothing in the world wrong with dividing by 1/3 on both sides. I just need to make sure that if I'm going to do it that way, that I type it in that way. You got to remember to enclose both sets of fractions in parentheses. You want to take 1/12 in parentheses divided by 1/3 also in parentheses. Which gives you an answer of 1/4 when you change your answer back to a fraction. If you want to check, you have 1/3 times 1/4. Get your answer as a fraction. That should turn out to be 1/12. Now what about this last monstrosity we see here on this slide? I have x over 4. It looks like a fraction, but what does a fraction bar stand for? Fraction bar is the same as a divide sign. So essentially I have x divided by 4, and if I want to do the opposite, that means just multiply by 4. X divided by 4 multiplied by 4 leaves me with just x. On the right hand side, -7 multiplied by 4 is -28. And if you want to check and make sure that works, plug in -28 into the original problem, and I have -28 divided by 4 does give me an answer of -7. The last few equations we have is going to take us more than one step to solve. So if I have to take more than one step to solve it, I need to decide what I do first. Here's my dividing line. Here's my variable. I have a +1 and a ×2. Which do I do first when I'm trying to get my variable by itself? I can actually do either, but the easier is to get rid of your add or subtract first. So in this case, I have 1 added to my x, so I need to subtract it from both sides. Follow the rules for combining like terms. 2x doesn't combine with anything that doesn't have an x. +1 and -1 cancel out. On the other side of the equal sign, 13 minus 1 leaves 12. Now I'm ready to get x totally by itself. 2 times x means that I need to divide by 2 to get x by itself. Divide both sides by 2, and x is 6. To check, back in the original, take out x, plug in 6, follow the order of operations, or type it into your technology correctly, and 2 times 6 plus 1 equals 13, so that answer checks. I want to get x by itself. I'm going to have to deal with the 8 and the 5. Subtract 5 from both sides first. Leaves me with 8x on the left. On the right, -43 minus 5 is -48. Divide by 8. And I'm left with x is -6. To check, +8 times -6 plus 5. Again, the easiest thing is to type it into your calculator, and your answer should be -43. Locate your equal sign, locate your variable. I got to get rid of a -1 first. I do that by adding 1 to both sides. Leaves the x over 9 alone. And on the other side, -7 plus 1 is -6. This is x divided by 9, so to get rid of a divided by 9, I need to multiply by 9. That leaves x by itself is equal to -54. If you want to check, you take -54 divided by 9, subtract 1, and it should work out to be -7. The last two, take what we were looking at one step further. Find your dividing line, find your equal sign. In this case, on the left hand side of the equal sign, I have two terms that have an x. I can't get x by itself if I have more than one term that has an x. So before I start doing anything, I need to combine like terms wherever I can. 4x minus 9x makes negative 5x. And the plus 3 doesn't combine with anything, so it comes down. Now look over here. I've got 7 minus 9. 7 minus 9, neither one of those numbers has a variable, so I can combine those. And I should. Once we have our equation to here, it's kind of like our little standard form. Now we're ready to get x by itself. So subtract 3 from both sides. And divide by negative 5. Don't lose your signs. And x turns out to be 1. Now when you check your answer, you want to check it back in the original. 1's going to go in every place there was an x. And what you want to do, type this entire side into the calculator first. Type the right hand side into the calculator and make sure you have the same amount on both sides. The last one, find your dividing line. Now this one's a little bit different because while I do have more than one term that has an x in it, they're on opposite sides of the equal sign. That means I need them both on the same side in order to be able to combine them. I'm going to take the one that's on the right hand side and subtract it. That amount from both sides. The reason that I did that is if I do that on the right, 2x minus x makes no more x's on the right, and it leaves me with negative 7. Most people prefer to not have their variable on the right, so we kind of wanted to make it disappear off there and have all our x's shift to the left hand side. On the left I've got 3x, take away 2x just leaves 1x. And the positive 7 didn't combine with anything, so it just comes down. Now I've got x plus 7, so I need to subtract 7 from both sides. And x is equal to negative 14. To check, I need to do 3 times negative 14 plus 7 on one side. And on the right, we've got 2 times negative 14 minus 7. So, on my calculator, I'm going to do 3 times negative 14 plus 7. And that gives me negative 35. On the right, I do 2 times negative 14 minus 7. That also gives me negative 35. And my answer checks.